All right, welcome. This is to the distance learning week 3 packet. This is for IM2. Here we have page 4. All right, so some notes that I want to give you before we work is what a discrete and continuous is. Right? So a discrete will be finite dots, okay? And continuous goes on forever, so it's going to be on an interval. All right? So here are some notes in a lot of details on what the domain is here and what the range is here. All right. So the domain here, you see how it's all continuous from this -7. The x value here was -7. The x value here was 5. Okay. The y value here is -3, and the y value here is 1. Okay. Notice it goes from -7 all the way to 5. It includes, do you see this? The bar? It includes that. Right here, it does not include because it's opened. Okay. And that's the range. Good. If you've seen the previous, the first week, no, sorry, Mondays, the first page and the second page, I kind of went over this. Okay, so if you want a better in-depth explanation, you should look at that video, okay? But I'm not going to repeat the same notes twice. Here's what a discrete looks like. Notice that the list is completely different. This is list by using an interval because it's continuous. But here, you actually have to list down its points because it is a discrete function. There's nothing in between here, okay? Look at the gaps. So you can look here, the x values here. The x here is 1. The x here is 8. So do you see how it goes? 1, then this is the 2, this is the 3, this is the 4. Nothing is included in between. 5, 6, 7, and 8. And if you want to look at the y here is 5, and the y up there, it looks like a 40. Okay, 5 to 40. Do you see how it goes? Then this is 10, right? And so on. Okay. All right. So that is the difference between writing the domain and range for a discrete function, and then this is how it would look like for a continuous function, okay? And we're going to use that idea for these set of notes, all right? So the first one, let's take a look. Let's label, first of all, our x here is -1, and our x here is 1. Our y here is -1, and our y here is 3. This is continuous. How do you spell continuous? C-O-N-U-O-U-S. All right, this is continuous. So again, so let's write this. What is our smallest value? It is the 1, -1, goes all the way to 1, right? And this is the x. Good. We include both of them. Okay, because it's both dots. Now let's do the y. Okay, the smallest y is -1. The biggest y here is a 3. All right, do we include both of them? Yes, we do. There you go. You could always follow this format of the inequality of like this if you go from least to greatest. Okay, good. And let's see. All right, let's go here. Interesting. Okay. All right, so this is very interesting. Okay. Let me read the question again. Something seems off. Identify the they just want the domain and range. Okay. All right, so let's take a look here. Here, again, this is going to be continuous. This is a continuous function. Am I spelling it right? Nope, there's no I here. I put coin. So this is continuous. Okay. All right, so let's look at our x values. What is our x value here? Do you see the arrow? The x value here is actually -infinity. Okay, and do you see the arrow here? The x value here is +infinity. So the domain goes all the way from negative infinity all the way to positive infinity. You don't put the bar under it because you cannot close down the infinity symbol. Okay, they go on forever. Okay, the range. Okay, this is the range. Your y is -1. That is your smallest, and it goes all the way to y is equal to positive infinity. So y goes up to all the way to positive infinity. Its smallest is what? -1. And you want to close it at -1 because it does touch the -1. Okay, but you can never close it at the infinity symbol. Sometimes if you want to write the plus here, you can, but we always assume that it's positive like that. This one is not a function though, just letting you know. I do not even know why they want us to do a range, domain and range. First of all, this is not a function. Okay, function. Okay, so I do not know why they want us to do this, but I will. Okay, so what is the x value here? The x value goes all the way. What is this? Goes all the arrows. So x is -infinity and goes all the way here. The x here is 2. So the domain is in between -infinity. Again, we go from least to greatest. So -infinity goes to way 2. We can never close down infinity. Can we close down the 2? Yes, we can. So we put the bar under it. Next, if you want to look at the smallest range here, the smallest range is y. Do you see the arrow? Doesn't stop, so that's -infinity. Up here, right? You see how it keeps going on forever? Goes to positive infinity. So y, in this case, for the range, exists in between -infinity all the way to infinity. Okay, but you wouldn't do something like this because this is not a function. But I did it ahead. Okay. Same thing here. This is weird. Okay, so what is my x value here? So hold on. I made the domain blue, right? So my x here is -4, and what's my x here? Is what? 2, right? Yeah. Let's look at my y. My y here is -2. My y here is going to be 2. Okay. Here you could write your domain and range if you would like. So fill it in, right? You're going to fill in the domain and range by yourself. Okay. You should be able to do this, right? Let me give you some assistance to help you along. So the domain, your smallest value, okay, whatever your small is, then the inequality, you're going to close it because it touches that x, then your greatest. Your y, your smallest y here, close it, y, that's your greatest, okay? Fill that in and you should be all set. All right, so let's look at 17 now. All right, 17, you kind of don't see it, but whatever. God, I hate this. They don't show it. Oh. So this is closed. Just letting you know this is closed. And this is an arrow. They don't show that really well. So what the x value here is what? What color did I make x? X blue. Okay. So x here, we could see it. It says -8. What is the x here? Oh, it keeps going on forever. So x goes to infinity here. All right. Do you see the arrow? Y. What is the y here? -2, and it stays at -2. Okay, because look, it touches -2 forever. So my range here is y is equal to -2. My range, no, the domain are my x values. So it would be from -8 all the way to infinity. And that is your x value. And you want to close it. Right? Can we close infinity? No. So you have to do it something like that. Good? All right. 18. Oh my gosh, again. So I want you to understand something here. Let me do the dots here. Do you see the dot? This is closed. This opened. Okay. The x value here is going to be 2. Your x value here is also going to be 2 because, again, your x values are your x-axis. Red are your y value, also your y-axis. Okay. So here, the smallest y you have here. What are you doing? So this is 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh my gosh. What is this? Oh my god. Hold on. So this is wow. This is so stupid. Because look, they're making me divide in half. So what is 2 divided by 1, 2, 3, 4, 5 divided by 5? So each one of these are 0.4. Really? Oh my god. So my y value here is equal to 0.4. My y value here is equal to 6. Okay. So what is your domain? Look, domain is x equals to 2, right? Your range, your smallest y is what? 0.4. Your y. Then you have your six here. Do you see how it's closed here? I wrote it closed here. So it's closed here. It touches the 0.4. It's closed there. It's open here. That's what I mean by open at the 6. Okay. All right. So this is actually very easy here. Okay. So let me just tell you that this is going to be continuous, and this is going to be discrete. Okay. For this one, for 19, you can look at 13. You could look at 13 for help. All right. And then for this one, you can, did I show a discrete one? No. Okay. So I could do this one for you. So the discrete here is looking at your, let's look at your x values first, okay? What is this? -2, -4, 3, 4. So this is x is equal, wait, what? So this is 1, -1. So this is -1. And this is 1, 2, 3. So x equals to 3, x equals to -1. So, okay. Let's look at the y. It just looks horrible. -5 goes all the way to 4, 6, 7. I can't see the numbers really. All right, so the domain here would be, let's say the smallest is -1, goes all the way to 3. This is your x. We close it, right? Nope, that's wrong. This is when it's discrete, when it's continuous, but now you want to write each one of these. So this is x is equal to 0, x is equal to 1, x is equal to 2. Then the last one is x equals to 3. You have to list them out. Same thing as your ranges. It starts here at -5. Okay. Then it has -2. Then this is 1. Then it's 4. This is 4. Then this is 7. That's correct. Okay. So 21. It says, are the domains of 19 and 20 the same? You would say no, their domains are not the same because 19 has a continuous domain. That's what I would say. And I would also include that 20 has a discrete domain. Okay. All right, so that's the difference between 19 and 20. They look the same, but they're discrete. One's 20 is discrete, 19 is continuous. That's how it actually would affect the domain and range. Okay.